Well, hey guys, it's Michael here. Welcome back to my video series on 420cc Predator-powered articulated mini dump truck build. This whole build I'm utilizing Subaru Legacy running gear, so it's going to be a four-wheel drive unit. Anyways, we'll get right into the video gear here. I think you guys are going to be pretty happy what I got done on this one. And if you're new to my channel or my video series, the next 30-40 seconds of video is going to be a little condensed version of part 1 and 2 to kind of catch you up to speed if you haven't seen any of these. Hope you guys enjoyed the video. Take care. So the entire drivetrain was parted out from a mid-90s Subaru Legacy wagon. And here I'm picking up the 420cc 13 horsepower engine from Harbor Freight. Don't worry guys, it's going to have plenty of power once it's geared down properly. I'm using 2x4-inch box tubing for the main components for the frame. Here I'm firing up my little tiny CNC plasma table to cut all the brackets and main components for this project. Like the transmission mounts and the hub mounts, all that kind of stuff I cut on that CNC table. Cutting down the old CV joints and shortening them for the narrower stance this thing's going to have. And turning down some bushings and pins on my lathe for the main center joint. Here I'm welding up all the components I cut on my CNC table for the main articulation joint. Alright you guys, I've been playing the waiting game, waiting on some parts and pieces off of eBay and a few things on Amazon, but I got my pillow block bearings I ordered a while back. I got some R16 ID 1-inch bearings. Got some 1-inch shaft, keyed shaft that was actually bought like 4 years ago from my band sawmill, just left over. I got 2 of these 1-inch shaft couplers. I got this in case I can't use the slip joint in this thing. I got a tractor 1 3/8 6 spline PTO extension, female to male. I was going to cut this off and put them together for a little slip joint if I need that. Suzuki Sidekick CV joint, front drive line. This is the side I originally wanted to use because it has the in and out. It's got a little bit of a slip, but it doesn't pivot as hard as this one. This is ideal for more steering capacity, but this is ideal for the slip joint. So I'm really not sure if I want to use this side and make it a lot easier on my life building this thing, or use this side and make it a lot more difficult. I only have 9.5 inches worth of material I can actually fit in between the bearings on here. So I'm gonna start cutting some of these things apart here and figure out what I'm gonna do. There we go. Alright, so I popped this joint apart off camera here, and this is the side that doesn't have any slip to it. It actually has a snap ring and you gotta pound this off. Well, I removed the snap ring, and what I'm thinking is I want a little bit of slip in this joint here in case it needs some for the articulation, the pivot. If I leave that snap ring out, this thing has probably about 1 inch to 1.25 inch slip. I think I only need 1/4 to 3/8, so that might be where I get my slip joint actually out of that. And I wanted to use this one because it has so much. It's got about 45 degrees. So I'm going to take this over to the lathe now. I'm going to cut this off here, and I got my 1-inch coupler I cut down, and I'm actually going to turn this down to 1 inch and fit this to it so I can weld it. So I'll bring you guys back when I get this wrapped up here. Man, that CV joint metal is hard as hell to cut through. Even with carbide, it still takes a lot of work. There it is, and here's the cut down coupler. Now I just need to weld that in. Should be good to go. Alright, so I'm working on a little bit of a bearing mount for the R16 bearing here. I'm going to be cutting some 1/2 inch, and I had to cut some stuff for my work recently, and I was having problems with a lot of metal blowback on the tips for piercing. And a few of my friends that have plasma tables, my buddy Dave especially, told me to drill some little tiny, like 5/30 seconds holes for little pierce holes right where you start your cut. And definitely makes a world of difference. So we're cutting some 1/2 inch here, and I got my 2 pierce holes right here and here. We're going to cut this part out now. So that turned out pretty good. I'll post some cut feed speeds and amperage on the side here so you guys got an idea if you have one of these tables or a similar table. Pretty clean. So here is that kind of overkill for that bearing mount. If I would have had some 2-inch ID tubing, I probably would have used that as a bearing mount part of it. This is what I had kicking around, some scrap, so I've used it. And this bearing is going to go right here, and this is going to get welded on as a carrier bearing, low profile. And the reason why I'm not using this needle bearing that came in stock in here is I'm trying to utilize a lot of that 1-inch keyed shaft that I have, and this is a larger diameter. I can't remember what it is. It's something in millimeters. I'd have to build a seal and some things like that, and this R16 was a sealed bearing already. Simple, super cheap, off-the-shelf parts. So I'm not going to bother with that bearing in there. I'm just going to utilize this thing. It's going to get mounted like that. So, quick note, the reason I ordered a Suzuki Sidekick front driveline was last year I was working on mine. I had to pull the front diff out. And I remember it had a 3-bolt flange on it, and I was potentially really ordering it for this flange part. That's why I ordered this one, but then once I got it, I realized it didn't actually pivot very far. So we're using the other side. I think we made do with the slip joint, figured that one out. So anyways, I'm gonna cut this thing off right here and try to wrap this joint up. So just switching out the discs on this 4.5-inch angle grinder. If you guys ever get these things with the spanner wrenches, you always lose them. Just tape them to the cord. It's a simple way. You're really never going to lose it that way. The tool companies can't get smart enough just to make them so they just insert and lock into the handle. That's a simple thing. I've only found one angle grinder. It's a cheap Ryobi that actually had it that way. Makes sense just to keep it in the handle. Now, because this part of this little stub shaft on the CV joint is actually smaller than a 1-inch, and this is a 1-inch coupler, I'm actually going to put a little weld around this thing, turn it down on my lathe till it's a nice slip fit for 1-inch, and weld them up. Even though weld is hard, this still cuts a hell of a lot easier here than dealing with this CV joint. Like, that cuts like nothing compared to how hard the CV joints are. So I'm pretty happy with this little custom CV joint turned out here. I got the slip joint that I need. It's got the massive pivot, steep angle. That part that fell off there is the bearing. Good thing it's built like a damn brick house. Anyways, so that's gonna fit up like that. Should be good. Ah, damn battery. Guess that works. So I got the input part of the drive line here that goes in the Subaru transmission, and I got one of those couplers I cut down, get 2 parts out of it, and I'm gonna put this in the hydraulic press here, make sure it's all lined up, and tack weld it together. So I've blown through most of my 1/4 inch plate here. This is about one of the bigger scraps I have from the original plate. This is about all that's left over that 1/4 inch sheet that I had, the 2 foot by 4 foot sheet. So I made good use of it so far. There's still some pieces I can get out of this and a few more gussets. Pretty efficient. Just picked this up the other day from the fab shop. They had a little scrap remnants of it. I think I got 20 or 25 bucks, something like that. Luckily, we only have a little bit more 1/4 inch we really need to cut for this thing. Just some gussets and stuff after this secondary plate. Should be done with most of the 1/4 inch on this job. So I decided to just pretty much build the rear frame off of the existing front frame because it was completely level in all directions. So I just set it up on some spacer blocks I already had cut here. And even though the frame is a lot shorter, it's a great platform to build off of. So I got it all tack welded here, and the frame's going to actually only be about 3.5 feet long in the back. And the reason why I'm doing that is the original idea is I don't want it super long to begin with, but the actual articulation joint's pretty long. There's going to be some 45s going off right here that's going to fit onto the back bearing. But the actual dump bed I'm hoping to do about 48 to 50 inches wide, and it's going to be about 5 feet long. And the back hinge is going to be somewhere here, and I want the back of the dump bed to actually hang off of this about 16 inches. So it'll make a little more sense as we get further along in the build. Alright, I'm pretty excited about this. My buddy Dave came over and helped me fit the rear end into this bearing mount here. And I just cut some various different gussets to stiffen up this back plate. So I'm going to actually weld these on now. It's getting a little late this evening. I kind of want to get to bed pretty soon. So I'm just going to do a little time lapse of me welding this. And then we'll get on to the next stage. So I pulled the sawhorses out in the back of the frame here, and this is super convenient for welding all sides of this thing. That's pretty nice.
Spin it again, a bit more gently, perhaps. Go ahead. Oh, my goodness, would you look at this? There he goes. He's in orbit again.
Alright, so I got the rear diff kind of where I think I want it, and I actually took all the measurements of these bolt holes, the diameters, and the placement of both of these brackets. I drew them up in Fusion 360. Now I'm going to go over the plasma torch and cut them out. Once we get them cut out, we'll drop them on here and take final measurements to finish off the rest of the brackets. So go cut them out next. This little CNC table I've been utilizing in these videos is called a Crossfire. It's from Langmuir Systems. If you look down below in the description of this video, there's a link to their website which you can read up more on them. There's also a little promo code down there which will save you $100 in checkout if you decide to buy one. And if you utilize that, you'll save $100, and it also gives me a little bit of a kickback, which helps me out to make more of these videos for you guys. Since I've got this thing, I've cut probably 300 to 400 feet worth of metal, from 1/2 inch down to, I don't know, 16 gauge. But a lot of the stuff for this articulated dump truck is actually 3/16 and 1/4 inch, and it's been working like a champ. Just have some extra consumables around. I'll put a link up here if you guys are interested to check out a review I did on this thing. Alright, let's get back to the articulating truck. So there's that rear diff mount I just cut. We'll see how it fits. Fits nice. What the hell? Oh, hell broke loose here. Looks like my tires just showed up. Nice. This is definitely a game changer for this project. To see these things here, it's one of those things I kind of rushed to order them a few weeks early because it'll probably be a few weeks before I can actually get rims bolted on here. Anyways, I ordered these things on Amazon. There'll be links below. Hey, if you guys need any tractor tires, check the description. But these are 14x7. They should fit my Subaru rims. They were super cheap. I spent more on a dirt bike back tire than these things. Each tire was $71 with free shipping. I mean, that is a bargain. They're made in the US. They're Carlisle. They are stout. They got some serious lugs on these things. So I think this thing's going to hook up pretty well when we get it running. I'm pretty excited about this. Hey, it sounds like a perfect time for a drum break. So I just got these tires mounted over at my friend Dave's house. I appreciate him helping me out with this project here. And actually I've had the rims over there for the last 3 years. He's been storing some Subaru parts for me over there. And kind of funny thing is, these nice little CNC brackets that I cut to hang these hubs, they're actually hitting the rims. So that's kind of one of those things, if you don't have all the parts in hand, sometimes it's hard to take those calculations. So I'll bring you guys around, show you what I'm talking about, but a little bit of angle grinding and they should be good to roll. I'm kind of actually surprised I haven't had to break out the angle grinder much before this to modify too many brackets. So there's the modified bracket. And it doesn't seem like there's that much clearance there from the camera, but there's actually, I don't know, 3/4 of an inch at least. Like having that CNC table, it's awesome. I'm just cut another kit out. This is for the rear hubs to mount those, and as you guys knew, I just had to do some angle grinding on the front wheel hangers. So this one's got a new steeper slope here, so it should clear the rim. And this one, because the back hub is slightly different than the front hub, I had to do this notch on the rear side to clear a casting. And these are different degrees. The fronts were 8 degrees, these are 5 degrees, so a lot of difference between the front and back. Oh, and they needed to be lengthened out another 1/2 inch to have the same wheelbase. So a little bit of calculation there, and I got these brackets all cut out, and we're gonna do some welding here and see how they fit. Alright you guys, hope you enjoyed the video. If you did, please hit like and subscribe. In the last 3 videos we've come a long ways on this thing, and getting these tires mounted on here and having all the hubs on this thing right now really solidifies the project, and you can see the potential here and what it's going to be like. Even though we didn't get the rear drive line hooked up to the rear differential or the differential hung, that's all going to come in the next video. But the cool thing is, I'm going to order a clutch and some chains, some sprockets and stuff. I think in the next video it's going to be pretty realistic to get the engine fired up on here. Maybe not drive it because we still need to work on some steering mechanisms, but we should be able to actually give it throttle and watch all the wheels, all-wheel drive wheels work here. I think that's coming up in the next video. So anyways, if you guys enjoyed it, please, like I said, share, hit like and subscribe, and leave a comment down below. See you guys next time. Take care.